Okay, so I've had some water and a little break here, and wanted to just kind of come back and so we've seen basically it build successfully, but now I want to actually make some changes, right? Use this kind of pipeline to actually push configurations to our devices, or new configurations. Obviously, we just push configs. So what I want to do here is basically just update the EOS host vars file. So in host vars here, really look at the EOS config, and we've kind of got sections here: Ethernet interfaces, loopback interfaces, blah blah blah. And basically, what I want to do is I just want to add a new loopback. So I basically kind of prepped this here, and we've got this new loopback 1. So I'm just going to go ahead and cheat, copy paste, and then also part of what this whole kind of thing is every time we make a change, every time we create a new configuration, change the way the network works, what we want to do is we want to be writing what would kind of basically be a unit test that actually validates that the change that we intended to make is doing what it isn't supposed to be doing, right? So in this case, we've added this loopback to the Arista box, and what we've also done here is we've added it to OSPF. So now, in theory, this change will get pushed in, new loopback gets spun up, added to OSPF, and then the Nexus device should be able to get to that. So we've created again, this is kind of hokey, but for purposes of a demonstration, it suits just fine. But we're going to basically create a new task in our validation thing playbook to say, great, let's test the reachability from NXOS1 to EOS1 and the new loopback. So we're going to just go ahead and ping, this is the new loopback IP address that I created. And again, we'll just source it from the original loopback. We might want to test this from multiple different places. We might want to use something like Todd or NetBees or some other kind of monitoring thing and have that be queried for reachability as part of like the pipeline. But again, just for kind of simple demo purposes, this will work just fine. And again, I'm just going to cheat, copy paste that in, and I'm going to really cheat and just use GitHub Desktop Client here. Add stuff for testing. We'll go ahead and push that up to the GitHub repository. So that should go, and we can go ahead and of course check that here. There we go, there's our new loopback. So perfect. We can go back to Jenkins. Another thing worth mentioning, in real life, this could easily be triggered via webhooks from GitHub. For this, obviously I'm just going to trigger this build manually, but basically every time that I have a commit to, in this case, my master branch, I could set up GitHub to go out and tickle Jenkins. I'm at an Airbnb, so like I don't have like a static IP address that I could NAT into Jenkins, and so point GitHub to that. But obviously, if this was a production network, you could easily set up a NAT or have like a Jenkins in AWS or whatever that looks like for you to go ahead and poke that. But again, for us, we'll just trigger that build manually. Just go ahead and refresh that to get that going. And of course, we're going to go ahead and see the console output just like we did kind of in the previous section. And the same stuff's going to happen, right? We already kind of know what's going to happen. Building the Docker container, checking out the GitHub repository, running all of our syntax checks. Then once we get through that, we're going to run that Python script. There we go. We see that it didn't fail or bomb out or anything. So the stuff that we entered is valid IP addresses, which of course it is. And the next thing we're going to do is test not having valid IP addresses. And off it goes. We can come back to our Arista device here. And looks like we should be there. There we go. Sure enough, loopback 1 now exists. We should be able to check for OSPF, and sure enough, that area or that network is now in area 0. And back on the Nexus device, we see it. We got our equal cost multipath across our links, so that should be good. Now in 30 seconds, when we go and we do our ping test, we should be doing something like 255 1.1 source of 255.2, I believe. And so clearly we can see that this ping is working. Hopefully our Ansible playbook thinks the same thing. So let that kind of chug along. And there it goes. And so everything's done. Everything was successful, so we didn't have to do a rollback. So we're going to go ahead and just destroy that Docker container. And we've gone ahead and added that. So that's pretty cool. Now, the next thing that we could do, and I'll just do this real quickly here. Where's my loopback? Let's just call this 256, which is obviously an invalid. IP address, valid IP test. Go ahead and commit that, push that up, and we'll go ahead and trigger the build one more time just to see. And perfect. We can go ahead and watch the console output, and hopefully this should fail relatively quickly because that Python script should say, hey, that's an invalid IP address, and throw an error code, which is going to cause Jenkins to abort the build before anything bad happens, basically. So go ahead and watch that. Getting through our syntax checks, all is well. And we can see that we skipped a bunch of stuff. Here we can see Python 3, validate user input, which is just that simple Python script. And it's saying, hey, greater than 255 is not permitted in this because, of course, that's not a valid IP address. So we've gone and skipped all of the subsequent stages and then finally cleaned up the workspace. Here we have the error message, integration testing failed, and we see that the build was aborted. Now, if I go back to Jenkins, I can see, I've got all of the history of what happened on each of these builds. Now, in real life, obviously you could have this fire off an email. Maybe there's a Slack channel dedicated to the build. Maybe there's a build per site or branch or something like that. So obviously you can kind of re-swizzle this to make it what you want. Now, I know one of the questions that came up on the podcast or the VDC or comments was, how is this something you have to manage everything in your network pervasively like this? And the answer is, of course, no, or it depends. It certainly doesn't have to be. I think there's definitely some value in doing that, particularly when we're doing the config replaces, like how we have our playbook set up to do. And in this way, you could have your network administered in almost like a Puppet-like or Chef-like deployment model, where, in a Puppet model, let's say you're administering an Apache server and you want to make sure Apache's installed, it's of whatever version, and the service is up. Now, Puppet by default is going to go out and tickle that box every 30 minutes, or the agent on the box is going to go ahead and validate that the Puppet manifest hasn't changed and that the state of that Puppet manifest is, in fact, the state of what's on the system. So when we start to administer the network in this type of way, where we're wholesale replacing configurations, we can start to kind of administer our network in a similar way. Now, if somebody was to go ahead and log in to this NXOS device and create a new loopback, we'll just say, test, and write that. And then if we went back to our let's just go ahead and delete this loopback1 stuff, and somewhere in here, delete the new loopback test. I think I need to delete that as well. And then let's just say revert for the message. Now, if I was to go ahead and push, so I created this loopback 99 manually. Now, if my build gets triggered, that loopback 99 is going to disappear, right? So that's both good and bad, and it really kind of depends on your perspective or what you're trying to achieve. It's good in the fact that this is certainly a way that we could eliminate config drift by having, basically eliminating manual intervention through your network. So if everything could be gated through this, or you could really run this in a very modern kind of like similar to like how you would roll out Docker images. This could be a way to administer your network. Now, obviously, that's not going to work for everybody, but it's certainly one way to do it. And it doesn't necessarily have to be config replace. It could be config merges. You could just run all of your changes through this type of a pipeline. So it doesn't necessarily have to be wholesale rip and replace. It could be, here's the playbook that I've built to accomplish change window, XYZ. Here's the validation playbook. And instead of manually running these playbooks, we're rolling it through Jenkins, and then you've got kind of historical, I guess I'll say, evidence of what happened. Obviously, again, this could go out and tickle Slack, and we could have all the messages there. So it could kind of put everybody on even footing so that everybody kind of sees, what's happening all at the same time. And then there we can see loopback 99 is obviously gone, and our build is kind of continuing. Hopefully we'll, get through validation and everything. And everything will be good to go. But anyway, I just wanted to kind of put this together as obviously this is a lot more time than I had on the VDC, and I'm still feeling a little under the weather, but I think I can actually talk straight now, so hopefully this made a little bit more sense. Feel free to hit me up on Twitter or GitHub issues or whatever. Happy to kind of talk about this a little bit more. And we can just kind of wait for this to finish up. Oh, yeah, there we go. Our pipeline succeeded, our network's back to normal, and all is well. So thanks, everyone.